Yo, what's good, guys? Today we're going to be going over integration by parts, and this is a calculus 2 concept that is quite useful for integration. It's think of it as like a u sub, but like with one extra step of the dv, and you having to use this formula right here, this uv minus integral of v du. This will set up the integral, essentially. This will basically answer. If you can get this and then do a derivative and a easier integral, then you can basically just plug in here and you get the answer. So the first thing that you should be asking yourself when you look at a problem like this is first if u sub works. If u sub doesn't work, and it's not like it's not just like an obvious integral, then you want to use integration by parts. And the way that you do that is by looking at your problem and finding a u and a dv, noting that you have to also find later on a du and a v. So whatever your dv is, it has to be able to be done by an integral. Um, and then same thing with du, has to be able to be differentiated. So and keep in mind when you're doing an integral from dv to v, you can end up with another integration by parts. That I've seen that happen before. Um, that happens a lot in like physics problems. Um, so finding your u and your dv is the hardest part of doing this problem. So to help out with what your u should be, eventually, if you do enough of these problems, you will get a feel for what u should be when looking at a problem and what dv is. Um, but like here's just an acronym that you can use just to find out what u would be equal. It's just which if you it's like sorted. So first you have logarithm. So if you look at like a problem and there is a logarithm, uh, then that's what your u is. And then inverse, if there's not a logarithm but there's inverse trig, then that's what your u is. And then same thing, algebra, if there's not inverse trig or logarithm, and you just go down. And you end, if there's nothing else but exponential, then that would be what your u is. So looking at this first problem, I know I need to find a u and a dv. It might not seem obvious what my dv. Well, obviously my u is just gonna be ln of x, because looking at the acronym up there, logarithm is the first thing, and ln of x is a logarithm. So that's gonna be what my u is. Um, Also, if you do enough of these problems, you will just know that ln of x is always pretty much just your u if it's in there. Um, dv may not seem obvious because you may think, oh, there's nothing else here. Well, you can multiply this entire thing by 1 and make 1 your dv because it's still the same. It's like u sub where like you make x your u and then your du is 1, so you don't even have to worry about making the equation work for a du. So you can plug in a du. You just can plug in whatever because 1 times anything is just that same thing. So du, so looks like a v, du, and v. So to find du, you want to take the integral of this, which in this instance, ln of x, the integral, or the derivative I mean, is 1 over x. And then the integral of 1 is just x. You don't add plus c at this stage. You will at the end if it's not a definite integral, but you don't need to at this stage. It just complicates things. So your formula is uv minus integral of v du. So we're just gonna plug straight into that with this. So uv is x, yikes, x ln x. Also, I'm using absolute values just because I'm used to it. I'm pretty sure it doesn't matter whether or not you do. So x and then du is 1 over x, which is just x times 1 over x is just x over x. So this is just 1, so this is just the integral of 1. Dx, I should have wrote dx here. So this is just x ln x minus integral of 1 dx, which is just x ln x minus 1 plus c. So this is the coveted integral of ln of x. Okay, moving on to the next one. So u equals dv equals v equals du equals. So looking at this, I see that I have an ln of something. So I know that this is going to be my u. Note that I also have trig, but since logarithms are before trig, it's you see ln and then trig. It's more important to do your logarithm first as your u. It's basically in that acronym. It's whatever comes first is whatever is first in that acronym. If something, you know what I'm saying. Ln of cosine of x is that, and then the derivative of this, if you know if you know 1 over x, it's just the derivative of the thing over the thing, essentially. So the derivative of what's inside of the derivative of cosine is negative sine x over, and then what's actually inside is cosine of x. So this is your derivative. You might also notice that this is just negative tangent x, but just because I know how this problem plays out, I'm not going to do it as negative tangent x. But yeah, you could write, if there was like a secant somewhere in here, you could do this, and then you would just, and then you would be able to do secant times negative tangent x is just like whatever that integral is, because that's some trig. That's like the something. That's just some secant derivative thing. But in this instance, since I know how it plays out, I'm not going to, but this is just negative tangent x. So dv has to be sine x because it's the only thing left, other than 1, but if, if it was 1, sine x would just still be there. So then the integral of sine x is negative cosine x, because the derivative of cosine x is negative sine x. So we have to make that negative to make the negatives cancel out. So uv minus integral of v du. So negative cosine x ln cosine x minus v is negative cosine x times sine over negative cosine x. You see how I just moved the negative down because it doesn't make a difference, but I just want to be able to, not have to deal with any negatives. If you made this, you would just have a negative sign inside, which would just give you cosine, and that make it, you'll see. You would just be integrating a negative sign instead of a positive sign. So I'm just going to cancel these out. So that gives me this. And we should know what the integral of sine x is. It's just negative cosine x. You should be able to see that since it's negative minus a negative, it just becomes positive here. Okay, so this is your answer. So here I already have my du written out. So what I'm going to do here is look back up at look back up at LIAT. I know that it's exponential because e to the negative 3x, so e there, and then looking back at it, I had an x, so x is algebra technically. So x is going to be my u, and 1 is going to be my du, and then that, this basically is my dv. So the integral of this, we know that we have to make it so it's 3 times something equals 1. Negative 3 times something equals 1, so we know it has to be negative on the outside. And we know it's got to be like a fraction. So 3 times something gives me 1, so it has to be a 3 on the bottom. So negative 1/3 e to the negative 3x. We just keep the negative e to the negative 3x because this always stays the same when you integrate or differentiate. So, yeah. So uv is just negative x to the third, or negative x over 3 e to the negative 3x. You could also just write this under the x if you wanted to. It's the same thing. Minus integral of v du times 1. So this 1 dx, this 1 doesn't mean anything really. Damn, I'm just not writing dx anywhere. So this 1 doesn't mean anything, obviously. So we're just going to realize, like, okay, what times 3 gives me 1/3? Negative 1/3. What times negative 3 gives me negative 1/3? So we know it has to be positive because a positive time, because this is going to be a negative, so we know it has to be positive something times 1/3. And we know it has to be a fraction because we ended with 1/3. We ended with a fraction. So something times something times something will give me this. So 3 times what denominator? Or essentially, it's just 1/3 of what denominator equals 3. 1/3 of what gives you 3 is another way you can think about this, which we know would be 9. Just, 3 over 9 is 1/3. And negative 3 times positive 1/9 is negative 1/3. So that, and then this stays the same. So your answer is negative x over 3. Make sure that if you did write this underneath the x that you make it positive because it's technically not negative. Yep. And I'm sure that you could do some like with this instance, I'm sure that you could do some simplification. Actually, it's a definite integral from infinity to 0. So this is not the right answer. My bad. Just have to evaluate it there. So what I'm going to do is just plug in infinity. Okay, so this approaches 0, obviously. Now this here's sort of like, if you remember going back to limits at infinity, you know that it's not about what the top and bottom are necessarily equal to. It's about which one really grows faster. And any exponential, especially when it's like e to something, grows much faster than just any algebraic expression. So this is going to 0 as well. Do you should basically see that this negative x on the top doesn't really mean anything because this 3e to the 3x is going to grow so much faster and be so much bigger at any given point than this x will be. Like if I plug in 500,000, this is going to be much bigger than just negative 500,000 because it's e to something times 3, which is, it's crazy big. So this equals 0. At infinity, this equation equals 0. And then if I plug in 0, you should also be able to see that negative 0 over whatever, over your 3e to the 0 is still just 0. So this is just 0, and then plus 1 over 9e to the 0, which this equals 1. So it's just 1 over 9. So your answer here is, since it's 0 here, and it's plus 1/9, or minus 1/9, my bad, it's just negative 1/9 is your answer. Because we did fundamental theorem of calculus between the two boundaries at the point, so we got negative 1/9 as my answer. uh, integration by parts is really it's useful, but it's one of those like it's really kind of like uh, how do I say? Like it's really specific and doesn't really work for a lot of instances, especially like actual integrals that you'll be having to just like get on like an FRQ or something like that. Unless the problem is like specifically designed to test integration by parts, you're probably not going to do it because it just takes a lot of work sometimes, especially when you're doing definite integrals. And it's really just a matter of can you see UDV. So I hope this helped, and XD.